we're going to factor by grouping because there are 4 terms here. The normal X or diamond factoring doesn't work. So the weird way you do this one by grouping is you're going to be doing some groups. So what I'm going to do first is I'm going to group these 2 together and these 2 together. And I'm going to pull a GCF out of both groups. So for the first group, the red group, what is a GCF in these 2, out of these 2? And hopefully you can see it is 3x squared. So I'm going to pull a GCF out of the first group. Once I do that, I'm left with 2x minus 1. Because if you multiply 3x squared times this, you get 6x cubed. If you multiply 3x squared times this, you get negative 3x squared. So I pulled a GCF out of the first group. Now I'm going to pull a GCF out of the second group. And so hopefully on the second group, you can see it is a negative 5. When you pull out the negative 5, you get 2x minus 1. And what you notice here is, do you notice these 2 are the same? If you're doing factoring by grouping, once you pull the GCFs out, these 2 match, and they should match. If they don't, keep working at pulling GCFs out. Since these match, it's a little weird, but what you have to realize is you have now 2 more terms. You have these 2 pieces. And you can pull a GCF out of these 2 because can't you pull 2x minus 1 out of both these? Because they both have something in common, a 2x minus 1. So if I pull the 2x minus 1 out, what are you left with? What are the 2 pieces that you're left with? Well, if you pull the GCF of 2x minus 1 out of both these, aren't you left with a 3x squared and a negative 5? So you're left with a 3x squared and a minus 5. And that right there is factored form. So once again, you take this group and pull a GCF out of both. What's left over should match. You then pull out that matching GCF as one more GCF, and your leftovers are there. If you were to do a box to this, to multiply it out, you'd go right back to this 4-term polynomial.